Now, you can actually run a least squares regression, which will take forever and is very tedious. Or you could just try to put a line between the two end points and see how it looks. So maybe from here to there. A lot of people would say, well, that's not going to be right. Chances are your line is probably going to go right through here. Because if any of you have taken a statistics course, you know that you want to try to fit the line where it's the same distance from each point. So if I was to really put a line through here for least squares, it would look something like maybe that right there. Now, if you was to continue this line out, you might be able to get it to hit that spot right there. It looks like it would hit that right there, which is 25 and 25. And then we'd have to find another spot. I'm going to try to find it right about there. So there's my least squares regression. Now this is by the eyeball. Now if somebody asks you to find a line and they tell you not to use a calculator or not to use Excel, this is the only way you can do it. To fit a line somewhere to where it is the same distance from all the points. So I'm going to use this point. I'm going to take the 2 points. Well, this mouse will work. I'm going to put a point here at 25 and 25. And then I'm going to try to use this point right here. I'm going to say this is 0 and 3. Now, if I have 25 and 25, then and 0 and 3, then I basically have 2 what?
Points.
2 points. Thank you. Appreciate you. Appreciate your interaction. One person.
Thank you.
Rest ignores me. All right. So we've got 2 points. Why don't they just put this thing in the middle of the table? And somebody's done this. Somebody keeps messing with this thing. Or they redo it. One of the two. All right. So we've got 2 points. 25. I'm sorry. 0 and 3. And 25 and 25. So use your slope calculation. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. X sub 1, y sub 1, x sub 2, y sub 2. And crank it out. Go ahead and do that. And then give me the equation for the line. So 25, 3, 25, and what? 0. So that's going to be 20 what? 22 over
25.
25. Now that's not reducible. You get 11 over 12.5. But the whole point is you're close to 1. So you got a slope that's basically close to 1. You could use a decimal here if you wanted to. Somebody divide 22 by 25. What do you get? Use your handy-dandy calculators that some of y'all can twirl around on your fingers like a basketball.
0.88.
How much?
0.88.
So I knew it was close to 1 because anytime these two numbers are close together, you're around 1. Either below 1 or above 1, depending on if it's proper or not. So we've got two slopes there, and you can use either one you want. Now pick a point. Well, you know which point I'm going to pick. I'm going to pick which one?
0 and 3.
0 and 3. So we've got a slope, m is equal to 22 over 25, or 0.9. You could use 0.9 if you want to. And then 0, 3. That's x sub 1. That's y sub 1. So y minus parentheses equals parentheses times x minus parentheses y sub 1 is 3, 0.9, and 0. So y minus 3 is equal to 0.9x. And your final answer is y is equal to 0.9x plus 3. Now, if I asked you not to use a calculator or not to use the computer, are each one of you going to get that same answer?
Hell no.
No. Why? What? I didn't hear that. What did y'all say? Will y'all get the same answer?
No.
Why? Why will you not get the same answer?
Because you were just like eyeballing that line. You just kind of made up 0, 3.
Exactly. I didn't make it up. I just eyeballed the line. Some of your lines may be a little bit this way. Some of you may be a little bit this way. But the whole point is, it's going to be very difficult for every person to get the same answer. Somebody may get y is equal to 0.85 plus 2.7. Somebody may get y is equal to 1.3x plus 4. Okay, but the whole point is it's going to be around this area. Now, to get it exactly, you'd have to actually use the least squares regression, which is a very tedious formula, but your calculator can do it. What you do is you put the points in the calculator and you find the statistics. The way that you do that is you pull up your handy dandy calculator. And you put the points in. So let me pull the problem back up. And let's put the points in. So we go to second. Is it list? No. Which one is it? Second. I don't use it very often.
Is it just stat to get
Stat. Thank you. Sort. Thank you. I don't use it very much. 2. 12. 14. 16. 18. 20. 22. And then in line 2, which is your second column, 7, 11, 13, 15, 17, 19, and 21. Okay, put the points in, then you hit stat, calculate, and go down to linear regression, number 4. Hit enter, and it's going to read L1 and L2, but go ahead and put it in. Second, L1, comma, L2, and enter. And there it is. Now they got a slope of what? 0.71. I initially had 0.8 what? 0.88?
Mm-hmm.
So there, and theirs is more, the calculator is more detailed because it basically calculates, it basically lets a line float in here and it figures it by the least squares until it gets it exactly right. And we don't want to do that unless y'all just glutton for punishment. All right? Then the y-intercept is 4.2. So your answer, as far as the question goes, is y is equal, what is the linear model for the, so you would punch in y is equal to, hold on a minute. This would be so much easier with a board. Just give me a second. Not gonna. There. So you would type in y is equal to 0.7. It says, what does it say? Round of 3 decimal places, 0.707x plus 4.217. All right, who has a question there? And you should feel good about yourself. There you go. So the whole purpose of this problem, is this a test question? Yes, a test question. But it's a good question for your calculator. This is one time that I will tell you that it's better to use the calculator than it's better than to do it by hand. But it's very important for you to understand what you're actually doing, and that's what it's doing. All right?
Are we allowed to use our calculator on our test?
Yeah.
Okay, cool.
As long as you don't abuse it. I'm not going to sit here and look over your shoulder. Oh, for the online test, yes. I will be looking over your shoulder for the online, for the in-class test. I'm sorry. Whatever. Okay? But yes, you can use your calculator for that. If I was to give you 10 problems, this would be maybe 1 or 2 problems right here because it's essential that you know how to do this on your calculator.
So to do it without a calculator, you would just take like 2 points somewhere on the graph and just do the whole point slope formula and everything, right?
You would have to get a good guess.
Okay.
See, like I told you before, when you plot the points, that's not a straight line.
Yeah.
Now, you might think you could do this. That's not correct. All right? You can't do that, and you can't do this. All right? The line is somewhere, if you was to draw the least squares line, the least squares line would be somewhere in here.
Yeah.
And that's where the AMB, and whatever the word is, okay? The variance, I can't say it. Ambiguity. Okay. Ambiguity. How about that?
Ambiguity.
There,
Yeah.
thank you. Or the variance. The red line, each one of you, if I've got 16 people in this class, there's going to be 16 different red lines. Maybe 1 or 2 of you may get the same line, but that's if you're sitting beside each other and you're helping each other. Okay?
Yeah.
Now, when you use the calculator, everybody will get the same line, unless you punch in something wrong. All right, so make sure everybody knows what the heck's going on.
It might be
Let's do another one. And this is important, so go ahead and do that problem right there. It should have changed it. Did it change it? 2, 12, 14, 16. I don't know if it changed it or not. Did it?
Yeah.
Let's look at the numbers and see. Stat.
This is the same.
Well, it shouldn't be. Edit. 2, 12, 14. Okay, I thought you could hit. All right, this is 2.217. So we'll take our handy dandy here. Right here.
I know.
Here. 2.217.
That's why. Mine doesn't. I just pushed enter. Yeah, I just pushed that count and then it does it.
Why 2.2 on, or 2, was it 2.3?
2.2 on the bottom.
Oh, 2.2, number 17. Okay, there's one. Now, of course, I'm going to have somebody say, I can't see it, I can't see it. So, let me do this. Open in Excel. Open. There you go. Now, let's make it a little bit bigger. Button. I don't know why they do that button. It drives me bananas. There. All right, find an equation for this line. Now you can do it. I want you to do it both ways. I want you to plot it. Use some kind of, I don't know how you're going to, if you don't have any graph paper, just do the best you can. Or do it freehand or do it on your calculator. But try to figure out where the least regression line is first before you try to do it on your calculator. I'll give you a graph so you can look at it. There you go. That's pretty straight. So you might be able to do this one without the calculator. Let's see how straight it is. Yep, that's pretty straight. So you could actually use the 3,000 and find another point. You probably, it looks like one point is off just a little bit. So it may not come out the right answer. So you better check it with your calculator when you get through doing it by hand. So I'm going to use 0 and 3,000. And then I'm going to use 2 and what? 3,500? 2 and 3,500. That's the points I'm going to use. Oh, 3,480, I'm sorry. I didn't look at the table. 3,480. I'm going to pull up my handy dandy. Move the stupid calculator out of the way. So there's my 2 points. So 3,480 minus 3,000 over 2 minus 0. And that comes up to 480 over 2, which is equal to what?
40.
So y minus 3,000 equals 240 times x minus 0, y is equal to 240x plus 3,000. That's what I got. Now, chances are y'all are probably going to come up with the same answer, if not real close, because the line is so straight. But I really don't think it's going to be that. It may be real close, but I think the calculator, because I see one point that's a little bit off. It could be because of my graphing, or it could be because it's intentionally supposed to be off. So what I'm going to do is put the points in, and let's see what you come out with. 0, 1, 2, 3, 4, 5, delete. Okay. And then 3,000. 32, 40. 3480. 3720. It's a whole lot of 3960. And 4200. And delete. And then stat, calculate linear regression. And second L1, comma, second L2. Well, it did come out right. 240 and 3,000. So that is our... Now they're probably going to ask you to predict something. And let's see what the question says. I have no idea what it's going to say. Can a linear function model exactly from the points of the table? Yes. Oh, that's it? Oh, there we go. Type equation. They usually ask you to predict something. Y is equal to 240x plus 3,000.
You have to put T for X.
Oh, whatever. Make sure you put T for X.
Yeah.
I'm not making fun of you.
No.
Making fun of them.
Oh.
Let him enter it.
Hold on a second. I got to fix my T. Oh, I got to retype the whole thing? Damn Russians. T. That's temperature, dork. T plus 3,000.
Maybe you could put S for Y.
Oh my God. Okay, it's right. Now that brings up a question. What if you do that on the test? I'll give you the points. I'm not going to sit here and split hairs with you. If you put y is equal to 240t plus 3,000, I'll take it. That's ridiculous. You know what to do. You know to plug in t or plug in x. You're going to get y. Just because you put down the wrong variable does not mean you don't know how to do the algebra. In my opinion, that's ridiculous. But you got them out there. I had a student email me. They're taking 109. Is there another one on the Pendleton campus?
Yes, sir.
They're failing.
There's
And
actually
I'm
two
like,
more.
you haven't even gotten through the first chapter yet. They have no idea what they're doing. And I'm like, you're kidding me. And they said, nope. I'm sorry, but if you're in Math 109, you should know what we're doing here. And what's happening is you get these teachers. I taught a class one time that got students ready for Math 110. And I basically taught everything that was in the 110 in that class. They'd go into the 110 and they wouldn't have any idea what's going on because of the teacher. So you got some that can't tell you how to get out of a wet paper sack. Use the model to find the future values of this investment at the end of the 7th year. See? They're asking you to predict something. So what are you going to plug in for T? 7, Hubert. That's right, class, because T means time. 7 years is time. Yes, that's right, class. So 7 times 240 is what? 1680?
Yeah.
Yes, Hubert. 1680 plus 3,000 is 4680. Somebody check my math.
Yes.
So you type in 4680 and you feel good about yourself. Is this interpolation or extrapolation from the data? I would say extrapolating. Why?
I don't know.
Y'all suck. Y'all really know that? Y'all suck. Interaction makes the class go faster.
Going higher.
And I would say extrapolation. Extrap. What does extrap mean?
No idea.
Extra means more
Yeah.
than that.
Yeah,
So-
that's real good. Yeah.
Yeah.
Going higher.
Okay, interpolate means that you take the data and you find the middle of the middle of the middle of the middle. You use it a lot with finding the square root. Okay? Text your friends. All right? Now, let me show you what I'm talking about. That's usually a warning shot. Somebody's looking between their legs again. Maybe they're fixated on something. I don't know. All right. Let's go right here and let's... If I ask you what is the square root of 18? Okay, and you say, well, the square root of 16 is equal to 4, and the square root of 25 is equal to 5, then I can say without any doubt that the middle of, notice I said middle of 4 and 5 is what? 4.5. So if the middle of 4.5 is the middle of these two numbers, then the middle of 16 and 25 should match up with 4.5, right? So what's 16 to 25? 9. Half of 9 is 4.5, so the square root of 20.5 is equal to 4.5. And I'll get the middle again. 4.25. What's the difference between $4 and $4 and $4.50? $4.25. So 16 to 20 is what? 4. Half of 4 is 2. 2 added on to the square root of 16 is square root of 18. So the square root of 18 is around 4.25 or 4.3. That's called interpolation. I don't know how to spell it, but anyway. Interpolation is taking half of the half of the half of the half. You're kind of imploding. You're bringing two numbers and you're going between them, and you're going between them. You see what I'm saying? Okay, got one person out of 16 that says yes, so that's good. That's interaction. I appreciate it.
So I was right. It's in the prefix. Enter going in, extra going outward. So it's
I didn't hear you say that. Okay, I'm sorry.
Well, I didn't say that, but that was kind of my implication.
You were leading that way.
Yeah.
Right, okay. Okay, I'll go with you on that. So interpolation means that you're including.
Actually, makes a lot of sense.
Okay, everybody was right. How about that? Okay.
Right.
Extrapolation means that you're going which way? The other way, meaning that you're using your data to what? Extend. Okay? That's why I would say extrapolation would probably be correct.
Sorry, I got
But
that
I may be totally wrong. Who knows?
Especially down there, I'm not telling.
Oh my God, that's right. Excellent.
Thinking, it takes too
So
long.
that's what the difference is between extrapolation and interpolation. Interpolation, you go inward with numbers to find the half of the half of the half. And extrapolation, we got our point, you got our line right here, and you use that line with the slope is equal to 240 or whatever it was to predict. Extrapolation predicts, where interpolation pretty much finds. You don't predict what the square root is. Is the square root going to be the same now? The square root is 18 going to be the same now as it is 20 years from now? Yes, it'll be the same. You're not predicting anything with the square root. With interpolation, you're what? You're finding. For extrapolation, you're predicting. Okay,
Hey,
whatever.
Mr. McClure,
Yes.
in this class, like when we're asked to find the square root of something that doesn't have like a, what you call it, like a perfect square root or whatever, like square root of 18. I just remember like in high school we were taught to like split it, so it would be square root of 18, then you split it, it's like 2 and 9, and then 9 is like 3 and 3, so it would be 2 square root of 3. Do you want us to do that?
That's called the perfect answer, the perfect root. And you can do that, but that's usually in algebra. And a lot of you saying, "Well, hell, Hubert, we're doing algebra." We are doing algebra, but what's everybody's degree in here?
Business.
Business, all right. Are you going to write? Okay, well that's 2 times square root of $3. No. Okay, so your answer is correct. We do usually write in algebra. Square root of 18 is equal to 2 times square root of 9, and that's going to be 3 times square root of 2. This is when it's like 100% algebra. Okay?
This is like real world numbers. So.
Say again, I'm sorry.
It's like real world situations. Like
exactly. This is algebra. So, and yes, you could write that, but not in 109 because 109 is going into business, and that is going to be 3 times square root of 2, which is going to be the interpolation method, which I showed you right there, the 4.25. Did somebody check? What's the square root of 18? Is it 4.3 or 4.25? Somebody check it right quick. Well, here it is.
4.
Okay, 4.2 what?
4.
4.24. So you see the interpolation here, and you could do this right here, 3 times 1.41. You could do that if you knew that square root of 2 is 1.41, but how many people know that square root of 2 is 1.41? You know, that's another if. So there's 2 or 3 ways to find it, but when you're dealing with plotting and you're dealing with real world numbers, you might want to use interpolation or the calculator. Okay? So those are 2 or 3 good questions that y'all asked there. And let's move on to the next homework question. Oh God, they logged me out again. What a surprise. This is 2.3, 17/7. 2.3, 17/7. Okay, solving systems of equations. Before we go into this problem, I want to go into quick PowerPoint because we only got 15 minutes. So let me go to it right quick. Hold on just a second. And I'll show you the 3 methods of solving systems of equations. And the reason I'm using the PowerPoints, I told you before, I usually don't use PowerPoints except on my online stuff. But I have to use PowerPoints in here because I don't have a board. So I know that sounds crazy, but that's the way. You just have to see my regular class and you know what I'm talking about. So let me get out of this. OneDrive. No, we were going to go into solving systems of equations today. Really? I hate 1-hour classes.
So,
Oh, I got a solving systems of equations in here somewhere. There we go. All right, here's the solving systems of equation. It'll be pretty quick, but we'll go over it again Monday when y'all come back. All right. There's three types that are basically used for solving systems of equations. The first type is solving systems of equations is finding the point where two lines intersect. So if you're talking about two lines intersecting, they usually intersect at a point X and Y. If the statement comes out to be true, which means 5 is equal to 5 or X is equal to X, then you have the same line, so the answer is all real numbers. So you need to write that down. Okay? If the statement comes out to be untrue, 5 is equal to 7, well, you know that's not true, and you haven't made any errors, then the lines do not intersect because they are what?
Parallel.
They're parallel. So you need to write that down. You need to write those three down. So if you're given a problem, and I'll go back to the slide in just a second. If you're given a problem and you're doing the problem and you come out with X is equal to 4 or 2. Damn it. I don't know why it's not doing what it's supposed to do. Okay? Well, there. X is equal to 2, and then you plug X is equal to 2, Y is equal to 2X, and you get Y is equal to 4. Then you get 2, 4. Okay? That's when you get X is equal to a number, and you plug it back in, and you get 2 is equal to 4. That's called a solution. 90% of the time, you're going to get something like that. All right? The second type problem, you're doing the problem and you get down to the answer and you get 5 is equal to 5. And you haven't made any errors. Well, you can't take 5 is equal to 5 and plug it into Y to get Y. So the answer is all real numbers because it's the same line. There is no intersection point. It intersects everywhere on the line because it's the same line. And then the third example, which is another 10%, because these two make up about 10% of the answers that you're going to get. Not all the time. Most of the time it's going to be this one. Number 3, you're going to come up with something that says 3 is equal to negative 4. And you haven't made any errors. And if you haven't made any errors, then that means that no solution, therefore parallel lines, meaning they do not what? Intersect. So when you're doing these type problems, you're going to get one of these three answers, and this one is the one that's most common. Now, the three types, what was that? I didn't know it was a call for a sneeze or somebody choking. All right, there are three types of methods. Here they are. The three most used: graphing, substitution, and elimination. Now, you can do matrices, you can do Kramer's rule, you can do elementary row operations, you can do identity matrix. There's all kinds of different methods, but it's kind of like the generic one is graphing, substitution, and elimination. That's what most of your Algebra 2s go to. That's what most of your college algebras go to. You don't get into the other ones unless you're taking a linear programming class or unless you're taking a matrix class. And they're fun to do, and I can show you how to do it, but it's not worth it as far as just reviewing, and that's what we're doing really in this first chapter, first unit. So, what do you do when you do graphing? Well, you just graph it. Now, graphing is the least accurate, so you need to put that on graphing. It's the least accurate. It's the one that you don't want to do. Why? Because some of y'all can't read a ruler. Well, some of you can't graph worth crap either. All right, and I mean that not in here. I mean students in general. Second thing, with graphing, you have to be very accurate. You can't use a pencil that hadn't been sharpened in 2 or 3 months. You have to use a very fine pencil. You have to use a straight edge. You have to use graph paper. Because the intersection point of 2 lines is going to be hard to find if you don't use graph paper. And if you're not accurate, if you do have graph paper, you're going to have the wrong point. So with graphing, it is the most inaccurate. Okay? So I would use it the least, unless the problem says use graphing. Here's how you do it. Usually the quickest way is to use method 2, and that's the intercept method. So you're given 2x plus 3y is equal to 6. Since y is not by itself, you're going to use the intercept method. Plug in 0 for y, you get x is equal to 3. That's the x-intercept. Plug in 0 for x, you get the y-intercept, and you plot those 2 points. Okay? Then you do this one. This one, y is by itself. So you're going to use method 1 or method 3, which is this method. And you plot those points. Basically, you plot the points, and see, it's hard to find right there. If you'll look real close, I'll move my arrow. It's hard to define what that point is right there. Why?
It's not meeting on the exact.
It's not on an exact corner. So that's why you don't want to use graphing unless the directions call for it. If the directions call for it, then chances are it's going to fall on a nice corner of 2 blocks. Okay? The next method is substitution. Now, the first thing you're going to look for with substitution is a variable what? That's isolated. This one right here, y is by itself. So what are we going to do with that 2x plus 4? We're going to take it and plug it in here for y. Since y is equal to 2x plus 4, we're going to take that 2x plus 4 and we're going to put it right there. And then distribute and solve. Now once you get x, what are you going to do with x? Back substitute into your original equation and solve. Now see, that's the same lines that we had in the first, but you didn't know where it landed. Well, look where it landed. It landed at fractions, and that's why it wasn't very pretty when you saw it on the graph. Okay, so that's the second method. Now, again, most of you should be saying to yourself, oh yeah, I remember that. I remember that back in Algebra 1, Algebra 2. That's what you're supposed to be saying. And then the third method is the elimination method. Now, I'm going to stop with the elimination method and let y'all work on the graphing and the substitution with your homework, because that problem you can do, that problem I pulled up. We'll go over this more Monday, because it does take a few minutes more to explain, but I'm going to leave it on the screen so you can take a picture of it. Oh, hold on. So you can take a picture of it, and you might be able to make sense of it, and I'll leave it up on the board for a few seconds so you can take it with you. But that's the third method.
Could you also go back to the first slide?
Yes.
Thank you.
Okay, take a picture right quick. I'll go back to it and leave it up. Just let me go back to the first slide. Which one?
The one that just listed.
No,
the one before it.
That one?
Yeah.
Okay. And then I'll go back.
Thank you.
All right, y'all get out of here. I'm gonna go ahead.
Wait. You got to do attendance.
I'm gonna give everybody's here today. I'm just gonna. You don't have to wait. Y'all have